Hello everyone and welcome back to another episode of our MATHFLEX. So we'll be continuing our lessons on analytic geometry. So this time we'll have parabola. So parabola is actually is one of the common curves that we study way back in our university or college days. So let's define first parabola. So parabola is actually a locus of a point which moves so that it is always equidistant to a fixed point called focus. Okay. To a fixed point, to a fixed straight line called Directrix. So what does it mean? Say for example, we have this example of parabola wherein it opens to the right. So, and our vertex at the origin, which is 0, 0, a point here which is called focus. So if you try to extend, or if you try to extend a line going to any point of the curve. Okay, so for example, at this point, this distance is always equidistant, okay, to a fixed line called Directrix, so which is this one. So this F is equal to D here. So at any given point that you will extend, so for example, I will extend this one here, okay, so this is F prime. So if I'll try to get also the distance between this point and our directrix D prime, so they are equidistant. So bear with me with our illustration, so they are not drawn to scale, but just to give you the definition or to explain the definition of a parabola, so this is what it means. So let's try to revisit the standard equations of our parabola. So we have all of these, we will encounter all the equations of parabola on these forms. So if the vertex at 0, 0, so what does it mean by vertex? It is the point wherein your curve start to shift into another direction. So in this case, our vertex is at origin. So if the vertex is at origin, so you have this form for standard equations. So we have y squared is equal to 4ax, which means that your parabola is opening to the right. So in this case, our example here is in the form of y squared is equal to 4ax since it opens to the right at vertex at 0, 0. Now, you have also another type of parabola wherein it opens to the left. So the standard equation is y squared is equal to negative 4ax. So in this case, our parabola opens to the left. Okay, so another type wherein you have x squared is equal to 4ay. So that means your parabola is opening up. Okay? And you have another one here, okay, wherein you have x squared is equal to negative 4ay. So that means your parabola opens down. Okay. Forms of parabola wherein the vertex is not at 0, 0, but instead it's the vertex is at hk or point hk. So it's somewhat similar to our first 4 equations here. So, but this time we are considering the vertex at hk or at point hk. So that means you have y minus k. These are the standard forms. So y minus k squared. 1 minus k, the quantity squared, is equal now to 4a times the quantity x minus h. So similarly, this is opening to your right also. Okay. Again, also the other equation here, y minus k squared is equal to negative 4a times the quantity x minus h. This opens to the left. So bear in mind that if your y is being squared, so that means it's either your curve is opening right or left. So you just have to identify the sign before your 4a here. So if it's positive, it opens to the right. If it's negative, it opens to the left. So similarly also for your, if your x variable is squared, okay, and your y is on the first degree, so that means your curve is either opening up or opening down. Say for example here, so x minus h, the quantity squared, is equal to 4a times the quantity y minus k. So it opens up, okay? Again, the other one is x minus h, the quantity squared is equal to negative 4a y minus k, so it opens down. So by the way, before we move to our equation, so what does a means here? So if you will see on our curve, so a is actually the distance between your focus to your vertex. So this is equal to a. And if your vertex to your directrix, since going back to the definition of your parabola, so that means from your vertex to the directrix, so this is also a. Okay. So again, I think to better understand more about parabola, so let's try to do some more examples. Okay, so let's try this problem. So it says the focus of the parabola y squared is equal to 16x is at, so we are given the choices here. So first and foremost, you just have to visualize your parabola based on these standard equations. So where is the vertex, okay? And where does your parabola open? So it's opening up, down, right, left. So that's very important to answer problems like this. So let's try. So y squared is equal to 16x. So this is our equation, the equation of our parabola. So y squared is equal to 16x. So going back to our standard equation, so it falls under this this form. So y squared is equal to 4ax. So which means that your parabola is opening right and your vertex is at 0, 0. So to draw your parabola, okay, so your parabola will be somewhat like this. Okay, so it opens to the right and your vertex is at 0, 0. Okay, then, so we are asked to find the focus, this F. So if you will recall on our introduction a while ago, so the focus is actually the distance between your vertex to your focus. The distance is a, right? So again, your equation says y squared is equal to 16x, and it falls under this equation. So y squared is equal to 4ax. So which means that your 4a here is equivalent to 16. So you have to equate those two. So 4a then is equal to 16. So therefore, your a value is equal to 4. Okay? So that means, okay, the distance between your vertex to your focus is equal to 4. Since your vertex is at the origin, so that means your focus is located at point, since this is on your x-axis, the point falls on your x-axis, so that means this is equal to, the focus is at 4, 0. Okay? So in this case, you have letter A as your answer. So again, if you will ask also about the directrix, so what's the equation of the directrix? So the directrix is actually equidistance, okay, to any given point of your is equidistance from your focus to your vertex. So that means if I'll extend this one onto the other side of your y-axis, or onto the other side, since it's equidistant, so this one is A. So that means you have your directrix here. Okay. which is at negative 4 at x is equal to negative 4. So that's the equation of your directrix. Okay, so let's have this problem. So we are asked to find the vertex of the parabola, which has an equation of y squared minus 4x plus 2y plus 1 is equal to 0. So the first rule here is to get the vertex of your parabola, they should be on this form, standard equation. So once we transform them on this form, so it's easy for us to identify the vertex of the parabola. So let's see. Y squared minus 4ax plus 2y plus 1. So by inspection, you would see that the degree, the highest degree is on the y. So that means it will fall on this form's standard equation, or it might be here. So it's either your curve is opening to the right or left. So let's see where it opens as we proceed with our problem. So y squared minus 4x plus 2y plus 1 is equal to 0. So let's transform this equation on this form. So all y to the other side and x on the other side. So let's see. Y squared plus 2y plus 1 is equal now. If you'll transform 4x to the other side, it will be positive. Okay. So it seems like it will fall on this, right on this equation. Okay. So if you try to factor out y squared plus 2y plus 1, so it will be y plus 1 squared, right? And you have 4x. So that means your vertex will be at k, negative k, so that means this is, the vertex is at, so this we have 0 here, so 0, h, and then k is negative k, so that is negative 1. So the vertex of this parabola will fall under, will be at 0, negative 1. So in this case, letter B is our answer. Okay, that's it for now. So we'll be having more problems on parabola on our next episode. So meantime, I just want you to continue to watch, like, subscribe, and hit that notification bell for you to get updated on our succeeding videos. Till next time, guys. Bye-bye. Ayun sila. Ayun, dalawang yan. Look at the Alexandrine. Sige, taas pa. Taas pa. Taas pa. Boom. Boom. Good. Go. Blaze and Nigel.
Okay. Okay.
Go Nigel. Go Nigel.